Okay, easy number 3. Does not look like we have as many numbers filled in already. Another technique, just so you know, is you can look at like this row right here. It already has a 1, it has a 3, but it does not have a 2. So I could click on 2 and be like, okay, well the 2 for that row has got to be in there or there. It has a 3, it has a 4, it has a 5. What about a 6? Well, the 6 has to be there or there as well because there's the 6, right? So now I know that the 2 has to be in one of those two, the 6 has to be in one of those two, so those two are the 2 and the 6. So now I have 1, 2's in one of those, 3, 4, 5, 6. I'm missing a 7, and I know that 7 has to go right there. So just another technique. I often look at it as I'm looking at different squares, trying to fill in the number in each square. But you can look at it as columns, you can look at it as rows, and as it gets more difficult, you will need to kind of rotate your thinking. That's part of what you're doing with Sudoku, is you're thinking about things one way, and then you're purposely stopping thinking in one direction and changing the way you think. And that's the only way to solve the very difficult ones. So back to my standard way of doing it, since this is still easy. These 2 columns are covered, so that's my 7. These 2 rows are covered. This column is covered, so my 7 is there or there. These 2 columns are covered, so my 7 is there or there. And then this one has actually 4 possibilities, which, as you know, I will refuse to notate. My 6's, this and this column are covered, so my 6 is there. Other than that, it doesn't tell me a lot about my 6's yet. This 5 and that 5 cover those 3, so my 5 is there. These 2 columns are covered, that row is covered, so there's my 5 there. This column is covered, so my 5 has to be in that column, which means that that column and that column are knocked out. This knocks out that row. There's my 5. Again, the note-taking pattern of matching, very important. Okay, so my 4's, this row is knocked out, this column is knocked out. I know this 4 has to be there. This column is knocked out, so this 4 has to be there. These 2 rows are knocked out, so it has to be in this row, can't be in this column, must be that one. These 2 columns are knocked out, so it's got to be in that column. These 2 columns are knocked out, it's got to be one of these 3. Normally don't mark it, but at least they're all in the same column, kind of worth notating. Okay, moving on to the 3. Look, this knocks out that whole column, so I know my 3 is there. This knocks out this column, this knocks out this one, so that 3 is there. And now both of these rows are knocked out, so that 3 is there. These 2 rows are knocked out, this column is knocked out, so my 3's are here. Again, this has that pattern. The 3 has to be one of those 2, the 7 has to be one of those 2. Those 2, therefore, are the 3 and the 7, period. Which one's which? Don't know. But those are, in fact, the 3 and the 7, and I don't need to think anymore about putting other numbers in notation on those. And again, with the easy ones, probably doesn't matter. But as you increase in difficulty, when you see a pattern like that, you need to remember not to put any other notes in those 2. Those are already decided. They're the 3 and the 7. Okay? So, let's see, we already did the 5's. Oh, the 4's, that knocked that out. We got a little bit more information. We were on the 3's. Okay, so this column, that column's knocked out. There's that. This 3 could be here, here, or here. Now let's look at that for a second. You see that I have, oh, there's 2 3's and there's 2 6's. Is that same pattern? Absolutely not, because the 3's are in 3 squares. If it was the 3 and the 6 were just in those 2 squares, then those are the 3 and the 6. But because the 3 could technically be over here, well, more than technically, could very well possibly be over here, those are not guaranteed to be the 3 and the 6. So you have to make sure that you have two numbers that are only in the exact same 2 squares, or 3 numbers that are only in the exact same 3 squares. It's got to be that pattern. If there are more squares than there are numbers filling them, then you cannot count those as, in essence, already decided. Okay, so the 2 has to be in one of those, has to be one of these because of those 2. See, like here, if I was going to notate a lot, and I don't, but if I was going to, I could be like, oh, it could be in any of those. But I would need to remember it can't be in that because that's already decided. It's only the 7 and the 3. And in fact, that's one of the dangers of over note taking, is accidentally not seeing some of these forced pairs. So I'm going to unnotate that. Here's a note worth making though. This 2 has to be in this column. Because it has to be in this column, that knocks out that possibility, forcing this 2 to be there. Because that 2 was in a forced pair with that 6, as soon as I place that 2, I now have the 6 is automatically placed. So this 6, by the way, has to be in one of those 2, as long as I'm notating quickly. All right, let's check out the 1s. This knocks out both of those columns. This knocks that out, and there's that. Also, that one was already knocked out because it was part of the 7-3 forced pair. But this column and this column are knocked out, so that forces that to be there. Now, we're going to see something right now that hopefully you'll find interesting. This one knocks that out. This one knocks that out. That means that this one has to be there or there. What you want to notice is when I put the 1s there, I said, oh, there's already a pair of 4s there. Are there 4s anywhere else? Doesn't appear to be. I'm going to double check. Sure enough, the 4s also have to be in there. So now I know one of those has to be a 1, the other has to be a 4. That 7, it can't possibly be a 7 because one has to be the 1 and the other one has to be the 4. So therefore, I know that that can no longer be a 7, and that means this is the 7. Hopefully that's helpful. I now know the 7 can't be there, so that 7 has to be there. Again, you could go, oh, look, there's the 7-3 thing right there. There's not, because the 3 could also be there. So it's not a forced pair. All right, starting with the 9s again. Now, I know this has to be a 9 because those are the only 2 that are left. I know that this 9 has to be in this column because, look, all these other ones have been filled in. So this has to be the 9, the 4, and the 6. That's all that's left in that row. I have the 1, the 2, the 3. The 4 has to be down here. I don't have a 6, so it has to be down here. I have the 7, the 8, have to have the 9. How is that helpful? Because if these have to be the 4, 6, and 9, well, then I can figure out what this has to be. The 8. Now, those 2 8s cover those 2 rows. These 2 8s cover these 2 columns, and there's that 8. This 8 covers that column. There's that 8. That 8 covers there, so this 8 has to be one of those 2. This 8 covers that row. This 8 covers that row. This 8 has to be there, forcing this 8 to be there. All my 8s are now placed. I now know that my 7s have to be in those 2. There is a complicated technique that we will cover more as you go into the more moderate and difficult ones that says we cannot have a 7-3, 7-3, 7-3, 7-3 situation. Because if these 4 all had 7 and 3 as the possibilities, there would not be one unique answer, because you could actually have the 7 be here, and this be a 3, and this be a 7, and this be a 3. Or you could have this be a 3, and this be a 7, and this be a 3, and that be a 7. And so, since if both of these were a forced pair of 7-3, we wouldn't have a unique answer, which is the point of Sudoku, is to have one correct answer. We know that these can't all be 7-3. Well, we know that this has to be 7-3, and this has to be 7-3, and this has to be 7-3. So guess what? This one can't be the 7 or the 3. It's got to be the 6. So that will come into play much more later, but what that does is that forces us to know all of these answers now. So this has 1, 2, 3, 4, 5, 6, 7, 8. It's missing its 9. We're going to put it in. That makes that impossible for the 9. And this is already the 1 and 4 forced fit pair, so that the 9 can't be there. So the 9's there. Now these two columns have 9s already. This one, and then one of these two is a 9. So that means that 9 is there. This 9 is in that column. Here we know this is the only place left for a 9. What does that do for us though? Well, it means that the 9 cannot be in that one because that column's covered, which answers a lot of questions. We were able to place several more 9s because of that. Still not sure down here. Okay, that 9 got placed, so therefore that one has to be a 2, which forces that one to be the 2, which forces that one to be the 2. This only has that left for a 2. That can't be a 2 because that can't be a 2 because that. So there's that 2, there's that 2. On to the 1s. No 1 because of there. No 1 because that. Must be the 1. Must be the 1. Now that that has to be the 1, this one must be the 4. And now this has to be the 4, and this has to be the 4. We now have only this left for the 9 because that's knocked out there. Only this left for the 9 because that one's not there, and that one not there. So there we go. And there's our 5s. Oh, hold on, we still got another one. There we go. And 6s. There, 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 and there you go.